Here is projectile motion UTEXAS question number 8. The data that you were given, and we're going to do 9 too. The data that you were given in question number 6, there are two things you still need to use. The horizontal velocity of 170, okay, that's the horizontal velocity of the plane, which will also be the horizontal velocity of the package. And then the vertical height, which can be vertical XF. Those two numbers that were given in question number 6 you need to use. You don't use any answers from it, but you do use those numbers. Alright, question number 8 is a little more basic than you probably think. You're given the horizontal velocity from question number 6. Mine was 170. And then it tells you that the package will be, in this case, thrown straight down. And my number that I'm given in question number 8 is 61. Okay? And all we need to do for question number 8 is solve for the actual resultant. All they want to know is what the actual velocity is when the ball is or package is released from the plane. So all you're doing is a squared plus b squared equals c squared to figure out the actual velocity. Alright, so 170 squared plus 61 squared equals an actual velocity of 180.6. Don't forget the square root there. Alright, here's question number 8. Now question number 9 is going to be the tougher problem. Question number 9, we're going to need to use this horizontal VI. So, you set up your list of givens. You have your vertical and your horizontal. Acceleration is 9.8. Acceleration here is 0. VI vertical is now 61, not 0. That's going to make the problem all tougher. VI horizontally is what you're given in question number 6. Mine is 170. Alright. XF is the height. Vertical, it was 4980. Horizontal is what we're looking for. T equals question mark. And it's going to be equal. Solve the time for one side, get it for the other. This is a problem where you cannot use the square root of 2xf because the initial velocity is not 0. So what we're going to do, I'm going to solve for a v final first. Then once I know v final, I can figure out the time it was in the air. And that'll get me back on track. So I'm going to use the vf squared formula because I have my distance and I have an initial velocity. So my initial velocity is 61 times 2 times 9.8 times my displacement, which was the 4940. So I'm looking for v final. Don't forget to square root your answer at the end. So I'm going to square root this whole thing. Get my v final to equal, I get my final velocity to be 317 meters per second. Okay, now I need to solve for time. So I can use my VF formula. VF equals VI plus 18. So, solve for T, I have VF minus VI divided by A. So, 317 minus 61 divided by 9.8. And I get, plug in my numbers and I get a time of 26.1. Then I go to horizontal. My horizontal final position would be velocity times time. My horizontal velocity was 170 from over here. Okay. And my time that I just got was 26.1. So I multiply those two together, and I get that my final answer, the horizontal distance traveled, will be 4,440 meters. And there is question number 9 of your UTEXAS projectile problems. See ya.